Okay, lots of my students have been having trouble with factoring, so I figured I will host a few videos to show that. And today I will discuss factoring the polynomial in the form of x squared minus a squared. And there's a rule in algebra that says x squared minus a squared could be rewritten, recasted as x minus a times x plus a. Believe me, it works. If you FOIL the right-hand side, you will get exactly the left-hand side, and I could prove it to you here really quick. Let's do it. So if we multiply through, we get x squared plus ax minus ax, because I'm foiling this, and this, and this here, and then this there. So minus a times plus a is minus a squared, and those two cancel out, and as expected, we get exactly x squared minus a squared. So the rule holds true, and now we can say that x squared minus a squared always factors into x minus a times x plus a. Let's take a couple of examples. So let's say we have, for example, x squared minus 16. Well, I know I could rewrite the 16 as x squared minus 4 squared. And as soon as you are able to write the second number, you can apply the difference, turn this into the factored form. So a in this case is 4, so you can just plug it into the rule, and this becomes x minus 4 times x plus 4. It's always x plus the number that is raised to the second let's say, for example, we have x to the 4 minus 81. And I know that I could rewrite the x to the 4 as x squared, and the 81 I can rewrite it as 9 squared. So now, in this case, my a will be x squared, and my b will be the 9. So now I can go ahead and apply the rule. So I will get x squared minus 9 times x squared plus 9. Now notice that my mission here is not yet completed. The reason is because I can still factor x squared minus 9 one more step by doing the exact same thing I did on x to the 4 minus 81, because 9 is the same thing as 3 squared. So I could rewrite this as x minus 3 times x plus 3 times x squared plus 9 cannot be factored, so it stays as x squared plus 9. I should add that this applies only when the polynomial is in the form of x squared minus a squared. This middle sign here has to be a negative. So for example, if I have x squared plus 16, I cannot do the difference of two squares on this one. You might ask, well, what happens if I have a number that cannot be casted into a complete square? For example, what happens if I have something like x squared minus 3? I know that the 3 cannot be written as the square of some other number. Can it not? Well, if you think about it long enough, it could be. It's a square of not necessarily an integer, but if you take root 3 and square it, you can potentially get 3, because the square root cancels the root and you would get 3. So I can claim that this is the same exact thing as x squared minus root 3 squared, and I can turn this into the difference of two squares by now saying it's x minus root 3 times x plus root 3. Now for those of you who are doing basic math there, this is not very useful. You don't usually do that on a 3 and a 5 and numbers that you cannot write as a complete square, but in college it comes handy and there's some utilities to it. I won't take it any further. I just figured I'd mention it. So technically, you can always factor a two-term polynomial if you think about it this way. That'll do it for this. Thanks for watching. Please do not forget to subscribe, comment, and subscribe, comment, and like. I cannot do this without you. Please subscribe to my channel. That way I can, the more subscribers I have, the more I can do, the more I can expand this channel to help others and enhance my students and your math skills to everyone who's watching. Thank you.